I think by and large, earthquake science helps us understand large magnitude earthquakes. And there is sort of a direct pipeline from basic science to sort of hazard research to actually action. My name is Amanda Thomas. I am an earthquake seismologist. I am the Louise Kellogg Chair of Geophysics and a professor in the Department of Earth and Planetary Science here at UC Davis. Along the northern coast of Venezuela, there's a place where two tectonic plates meet. The northern part of Venezuela on the north side of this fault is called the Caribbean Plate, and south of this fault zone is the South American Plate. And between them is a fault system called the San Sebastian Fault System. And so what happened is on the southwest side of the San Sebastian Fault System, there was this an additional what we would call like a branch fault called the Bocono Fault. And that Bocono Fault had at least what we at first thought was a very sort of standard issue earthquake. But then what happened is the stress change from that earthquake actually initiated slip on the San Sebastian Fault System. And triggered a second sort of follow-up magnitude 7.5 earthquake about 40 seconds later. I am a what we would call an observational seismologist, and that means that I use seismic data, so recordings of the vibrations of the Earth's surface, to try to better understand processes in the Earth. What processes dictate how strong faults are and how fast do they get strong after big earthquakes? And that sort of bears on the problem of, okay, this fault has a stress level that's here. Well, how strong is this adjacent fault? And what amount of stress do you need to sort of bump it up over its threshold, its strength threshold? One of the things that I'm very excited about right now is the use of sort of artificial intelligence and machine learning has made it possible to analyze way more data than we ever could in the past. What we can do now is design tools that go through and look at the data for us. And they tell us, hey, there's a little earthquake here, there's a little earthquake there, like ones that we never knew existed, we can find now. And I know little earthquakes, right? Like who cares about an earthquake that's the size of a dinner plate? Well, I do. And the reason I care about earthquakes that are the size of dinner plates is those little earthquakes delineate big faults. And there's examples, even as recently as this year, of us finding faults that we didn't know existed by looking at itty bitty teeny tiny earthquakes. Earthquake science research is important and necessary, frankly, because it keeps us safer. Big earthquakes like the one that just happened in Venezuela, there's a tremendous amount of human tragedy involved in this. But also every earthquake teaches us a lesson. And if you take and you have a group of scientists that are working on those questions, we ultimately end up distilling that information down into like an amount of knowledge that collectively advances earthquake science and helps it so that next time we build the buildings better. Next time we help make the response efforts better. We train more people in heavy machinery so that they can help extract people from buildings that have collapsed. We try to build buildings that don't collapse. So overall, I think like the research is very impactful for helping with public safety.